Mars moves into the neighborhood. The red planet is the closest it's been to Earth in nearly 60,000 years. That gives Earthlings an up-close and personal view and a great opportunity to study its nearest celestial neighbor. Jim Bell is a professor at Cornell University. He's with us from the Space Telescope Science Institute in Baltimore. Professor Bell, good morning to you.
Morning, Matt.
Let's go right to the videotape, okay? These are fresh pictures from the Hubble telescope, and I want to take a look at them. When I see this picture, Jim, I say, wow, nice colors, looks pretty good. What does a trained eye see?
Well, it's pretty impressive. We're looking with the Space Telescope at the closest, highest resolution view we've ever had of Mars from the Earth. Lots of interesting things going on here. We're seeing the south polar cap, the dry ice and water ice pointed towards us at the bottom of the image there, that whitish area. We're seeing bright and dark markings on the surface, the same ones that have been seen by astronomers for more than 300 years now, except we're seeing them in exquisite detail.
Well, that's
really,
a good point.
exciting.
Tell me, how much of an improvement is this image we're looking at right now from what we've had in the past?
Oh, it's a substantial improvement. Remember, the Space Telescope is above the atmosphere of the Earth, so we don't get all that twinkling and kind of contamination of the light that we get from telescopes on the ground. So we have a beautiful, clear view. And this today, actually, Mars and the Earth are closer than they've been for almost 60,000 years. So we're very, very close in astronomical terms to the planet, so we get lots of detail.
Yeah, when looking at a marking just to the right center of the picture, Jim, it looks like an enormous crater. What would that be?
Well, there's a bunch of craters that we can see in this image, and the one that's just to the right and below center is an enormous impact basin. It's called Hellas. It's a giant hole in the ground on Mars. It's one of the largest craters in the solar system. Usually it's full of clouds or dust storms or other kind of meteorologic activity. But in the images that we took last night with the Space Telescope, it's very quiet. It's a balmy summer day in that part of Mars.
And real quickly, the next time that Mars is going to be this close is the year 2287, I guess it is. By that time, you expect that we'll be standing on Mars talking about this firsthand?
Oh, absolutely. I think the Martians will be having all kinds of star parties with their telescopes looking at the close approach of the Earth in that part of the 23rd century.
All right, Professor Jim Bell. Jim, thanks very much. I appreciate it.
Thank you, Matt.
As scientists analyze the terrain and decide when and where the rover will make its first move. Joining me now is Jim Bell, professor of astronomy at Cornell University and the lead camera scientist for the mission. Jim Bell, welcome. Tell us first why Spirit is still sitting where it is and what's going on while it sits.
Well, the process of getting the rover Spirit off the lander is a very cautious one. We're in an alien environment, literally. We've landed in a configuration that we couldn't predict ahead of time. And so the first thing we have to do is take a very careful look around and make sure that it's safe to go off the lander, what the engineers call egress off the lander. And so we've been spending quite a few days now looking around, getting the lay of the land, looking at the parts of the lander that the rover might have to drive over or past. And so that's a very slow and careful process that the engineers are going through before we're able to drive down onto the Martian surface.
There was talk today about how the airbags that were there to protect the landing have bunched under the lander and may be causing some problems so that the rover will have to turn before getting down off the lander. Can you explain that?
Yeah, it's possible. Those airbags, which of course protected us as we bounced across the Martian landscape, deflated after we landed, but several of them, it looks like they didn't deflate entirely, so they're sort of bunched up. Maybe it's still a little bit inflated. And so some of the engineers are worried that if we drive down directly forward, we might scrape those materials or perhaps even get snagged, and that would not be a good thing. It's all about getting onto the surface safely so we can do the science we need to do. But the engineers have practiced a whole variety of different alternative possibilities. That rover can spin all the way around on that lander. We can turn to either side and go off either other side pedal. Or even between the pedals if we had to. So there are many different options, and they're going to pick the best one, the safest one, to get us onto the surface.
Okay, let's look at some of these amazing photos that have been coming back. The first one is the first color image of the surrounding area. It was sent back to Earth on Tuesday. Tell us what we're seeing here.
Well, we're looking at exactly that, the very first picture in color that was sent down. When you take a look at this view, your first reaction might be, wow, that's almost like somewhere in the desert southwest of the U.S., in Arizona or California. But when you look more closely, you can see that it really is not an Earth-like environment. For example, the sky is pinkish red in color because there's a lot of dust in the atmosphere. And the rocks and soil deposits are not like what a geologist would find on the Earth. For example, we were thrilled to see a variety of different kinds of rocks, different rock shapes, ranging from very sharp and angular, certainly scary to the airbag designers, to larger and smoother that we see in the environment. And so there are light rocks, dark rocks, variety of different forms. We see some materials that look like dunes, some brighter soil deposits, darker soil deposits. Off in the distance, we can see some of these enigmatic circular depressions with bright floors in them. These are a little bit mysterious. We're trying to figure out their origin, especially whether they might have anything to do with the water that may once have been in this large crater we've landed in.
Let me move to one that was released just today, an infrared terrain photo. Tell us what we're seeing here.
Well, in addition to this spectacular color camera that the rover carries, we also have an infrared camera and spectrometer that kind of gives us like a night vision view, night goggle vision view of the landing site. When we look in the infrared, we can see the heat energy, the thermal energy emitted by the rocks and soils. And so what we're seeing is an infrared image superimposed on top of the visible light image. We see areas that are red are warmer, areas that are blue are cooler. And the wonderful thing about this image, first of all, it tells us that the infrared instrument called Mini-TESS is working very well. It's very encouraging. But we also see a variety of temperatures, a wide range of temperatures of materials at the landing site. And the temperature of the material tells us something about its physical properties. For example, the reddish materials are very warm and fine-grained, probably dusty, maybe even fluffy. The bluish materials, and you can see some of them right in front there, there's a blue rock. Those are cool and coarse-grained, sandy or rocky. So we can use the infrared map and the visible pictures together to try to build a map of the landing site that'll guide us to the most interesting bright soil deposits or dark rock deposits. And of course, those are the things that we want to explore to learn more about this landing site.
And all of that, the temperature and these photos help you analyze the possibility of water once on Mars and potentially life.
That's right. One of the main goals of our mission, of our investigation, is to try to search for evidence about whether Mars was Earth-like in the past. And of course, if it was Earth-like, if it was warmer, if the environment was wetter, if the atmosphere was different, then that raises the possibility of there perhaps having been life on the red planet.
Now, one more photo was also released today, puckishly called Spirit Rises to the Occasion. And this, I gather, goes to what comes next for Rover.
That's right. You're seeing in this picture a wide-angle view from one of the fisheye cameras in front of the rover. What's happened over the course of the last week is that the rover is going through this series of unfolding activities, kind of like a Japanese origami puzzle. One part coming out, another part coming out, the mast going up, the solar panels, etc. The steps that were taken yesterday were to stand the rover up and unfurl those front wheels, and you're seeing those two front wheels there sitting down on the deck. That was a very, very important activity. The engineering and science teams were just really happy to see that happen. What it means is that we're one step closer to getting that rover off the lander and onto the surface. Now, what has to happen over the coming week is to continue that stand-up process to go all the way to the end. We will cut the last umbilical cord cable that connects us to the lander, and then the rover will be a free and independent spacecraft, totally disconnected from the lander. Then we'll be free to either drive down that front ramp or off one of the side ramps or side pedals, depending on what the engineers think is safest. We're looking right now at getting the rover off the lander towards the end of the week, next week.
Well, Jim Bell, thanks very much for joining us.
Thanks, Jeff.
This rover will spend the next 3 months looking for signs of life on Mars. It has a very impressive toolbox to help it carry out that task. Let's go to Ivan Semenuk in Pasadena for a tour.
Thanks very much, Jay. Now, standing with me here is the star of this entire event. It's the Spirit Rover, or the closest thing to it. In fact, it's a life-size model of the Spirit Rover. And here with me also is Dr. Jim Bell. He's a member of the Rover science team, and he's a man with a very important job. He's the principal investigator for the cameras on board the rover.
That's right, Adam.
Now, Jim, why don't we start off, can you just tell us where the cameras actually are on the rover?
Well, the cool thing about this rover is it's loaded with cameras. Cameras all over the place. There's 4 cameras up here on the mast. You're seeing 2 color cameras, the pan cams that I'm responsible for with their filter wheels, red, green, blue, infrared filters. Navigation cameras that generated this beautiful panorama that we took yesterday that you've seen in black and white. Those are black and white cameras. Okay. There's 2 cameras down in the front here called hazard cameras. There's 2 other ones just like that in the back, and there's another camera on the arm that we can talk about in a bit too.
And as far as the color cameras are concerned, I guess getting them up high on this mast has to do with seeing as much of the landscape as possible.
You want to be up just like we are, so you get a good view looking all the way around, a panoramic view. The head of this mast can spin all the way around. This bar here can tilt back so we can look up at the sky, we can look at the sun. There are special filters to look right at the sun. We can look behind us, we can look straight down at the arm, on the deck. It's a very, very versatile instrument.
And so what else are we seeing here on the deck as well? I know there are other instruments in behind.
Right. The deck is loaded with instruments. Of course, this is all a solar panel that gives us our power. We're a solar-powered spacecraft. Seeing 3 different antennas here. The high-gain antenna that we'll deploy today. This is to communicate directly with the Earth. This rod here is a low-gain antenna to also communicate directly with the Earth at a very low data rate. And that little stick there is a UHF antenna, and that's what we use to talk to Mars Global Surveyor and Mars Odyssey. So that's a pretty nice array of communications instruments. In the far back there is our little sundial calibration target that we use to get the colors right on the cameras too.
Great. Now, I know looking around and talking to Earth is very important, but the unique thing about this spacecraft is it also moves around over the surface. So why don't we talk about the part of the rover that's actually mobile? Tell me about the wheels.
That's
here.
right. The wheels are very much like the Sojourner rover from 1997, the Mars Pathfinder mission, 6 wheels. Each wheel has a motor in it. The front and the rear wheels can steer. This whole rover can spin in place using its wheels. The system, this rocker bogie suspension system, is designed to drive right over rocks up to about half the height of the rover body, so it just drives right over them like they're not there. And it uses these wide-angle fisheye cameras in the front here to find obstacles and avoid them. Gets these big wide-angle stereo views, automatically processes them on board so we don't have to be in the loop, really. It knows that I need to avoid that or I can drive right over it.
Great. So far we've got the camera to find the interesting things. We've got the wheels to take you to the interesting things. What happens next?
Well, then we bring this beautiful arm out, which you can see is about the size of a typical human arm. It has the same kind of shoulder, elbow, wrist, and on the end of the arm here, the fingers, there's 4 fingers, 4 different instruments, 2 spectrometers for chemical composition, a drilling device called a rat, you can see here deployed onto this rock to clean rocks off and drill small holes in them, and a microscope like a hand lens like a geologist would carry around the field right here. So we use this just like a geologist would out in the field to poke and move and prod and sniff and dig and do all the kinds of things that we wish we could do in person.
Now, I know weight is always an issue with these spacecraft, and I'm sure that all of these instruments were very carefully chosen out of a whole spectrum of possible things you could have taken. What is it about these instruments that will give you the best possible look at the geology of Mars?
It's a good question. The beauty of these instruments is that they all work really well together. We get pictures from up on high, from down low at a variety of resolutions. We get the color, which gives us some information on the composition and kinds of minerals that are there. There's a spectrometer in the body of the rover that looks up the mast like a periscope that gives us the mineralogy from the infrared, so we get another view of the kinds of materials that are there. When we find something interesting that might have to do with water in the past on Mars, we can drive up to it, use this beautiful mobility here, poke at it, dig at it, and determine its composition and origin.
It sounds like you've got a lot of work to do on Mars, but it looks like you've also got the tools to do it with.
We have an excellent tool, and it's working beautifully on the surface. It's more than we could have ever hoped for.
Great. Jim, thanks very much for joining us today. Dr. Jim Bell is a principal investigator for the PanCam, part of the Mars Exploration Rover science team. Back to you, Jay.